before, like with the last exam, I don't know when I think yours I had up on Saturday, right after spring break. At least you could check your grades. So you already knew that you did a good job. A few of you might be a little bit lower than the average. Well, obviously, that's the way averages work, right? We can't all be above average. But if you are lower than you wish you were in terms of your grade, as always, please do stop by at some point. We can talk about it and try to figure out strategies moving forward. I'm happy to help you get a better grade on your next exam. I mean, it really just is, spending the time and coming and seeing me, or finding a tutor that you're more comfortable with, if that's the way it is. But like I said, if you do have complaints about your exam, stick around afterwards. We'll probably have some time to talk. One thing to mention about the midterm grades is I submitted midterm grades yesterday, and I missed a couple of things. Well, just one thing, to be honest, when I was doing that. So your midterm grades are not, and in fact, Moodle probably isn't accurate either. For those of you who have chosen not to do the homework, I didn't enter zeros. That's the thing, is I forgot to do that before submitting the midterm grades. Midterm grades are kind of a holdover from like when I was in college. I don't know why we do them. We have Moodle that, it's like, do you even look at your midterm grades? I don't know. So, but just to warn you, later on this week, so you'll get your I don't know how it works. The registrar begs me, like the faculty, you're like, get your midterm grades in. I'm like, okay. But anyway, later this week, you might look on Moodle, especially if you're in that category of people who have chosen not to do some of the homework assignments, and you might see, oh, my grade's a little lower than it was just a minute ago. And it's because I would have gone in and updated the grades with the zeros, because that doesn't get done automatically. I was waiting so that people would have a chance to do their homework late if they wanted to. Okay, so, is everything all right? Questions? Oh, it played a video for you. I hope it's a good one. Okay, so it's okay. Yeah. Let's go on to this. This is fun. So we're all suffering today. I am suffering. You're suffering. I know, because of the time change, right? The time change. How horrible is the time change? Well, let's find out how horrible it is. So this installment of statistics you can use is all about the time change. If it'll work, there it is. And so there are a couple of studies that I found, recent ones, 2020. The evaluation of acute effects of daylight savings time on traffic accident risk. I bet you can guess what the conclusions are there, but here it is. We used a large US registry data, blah, 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 and found that the fatal motor vehicle accident risk after the time change increases by 6%. There were no effects in the fallback transition to standard time on motor vehicle accident risk. So the motor vehicle accidents increase after the time change, at least in this observational study, after the time change in the spring, which makes sense. We're all getting up earlier, we're tired. It's terrible, isn't it? Especially right after spring break to hit us with this. It's horrible. But anyway, so you might think that, well, at least we have good news from the fall, but that good news goes away when you do take a look at this other study. And there are more than this observational studies where that illustrate the harm that is done by daylight savings time, or at least the clock change. So in this study, these researchers were looking at patient safety-related incidents following transitions into daylight savings time. And they concluded that in particular, the week following the transition into and out of, so this is important, it's both into and out of daylight savings time, so it's both in the fall and the spring, there were increased reports of safety-related incidents in hospitals. So people make mistakes. The nurses, the doctors make mistakes, which can affect patient outcomes. So we have this this stuff over the 8-year period. We observed 4.2% and 8.8% increases in overall safety-related incidents in the 7 days following the time change, either fall or spring. So fall was only 4.2% increase, spring. So don't go to the hospital the week after either time change. At least try not to be in the hospital, because you might suffer from a safety-related incident. This though may this will be good, because I have another statistics you can use, but I don't need to do it now because I forgot that I have confidence intervals. This is what we're doing today. We're doing confidence intervals, and they have a confidence interval here and another confidence interval with a p-value. We're going to be focusing on confidence intervals for the first bit of time after spring break here, and then we'll move on to what these p-values mean. So confidence intervals first, though. So what can we do? Well, I, about 5 years ago, made this little graphic, and I thought, we need to abolish the time change. Maybe we should make t-shirts and ball caps and so forth and advertise, abolish the time change. Here's a water bottle thing. During the COVID, I thought, well, I could do this as well, have a mask. I know those aren't in vogue anymore, at least among people here. And then all of a sudden in 2022, we won. It was great. Marco Rubio pushed through an act in the Senate. So by unanimous consent, the Senate approved to get rid of the time change. And here's Marco Rubio. And I don't care what your politics are. I love Marco Rubio for this. That's the only thing I love him for. But it's great, isn't it? We don't have to keep doing this stupidity anymore. And why would we enshrine this in our laws and keep doing it for so long is beyond me. Anyway, so that happened. But then we lost because Nancy Pelosi didn't bother voting on this in the House. It would have passed, I'm sure. And so here's what we need to do. We need to contact your congressperson. I'm going to do this right now. I've saved this moment so that I could do it right here. Let me just show you how to do this in case you're scared or whatever. I'm also going to contact, so I've got, 4 classes today. So I'm going to contact each of my senators and my congressperson and the president, because he wants to be a strong president and he loves Marco Rubio now. He didn't like him a few years back, but at least now he does. So here's how you do this. You go into here, you find your, I know who my congressperson is, but if you don't, you can look it up by looking up your zip code. I think, yeah, zip code 43050 is me. And it's like, oh, which one of these people is you? It's this guy right here. But let's go ahead and we'll do my actual address and assure them that I'm not a robot as well, because they don't want robots contacting. So here he is. And then there is a contact. Where's the contact thing? Maybe I just have to click his face. Yeah, there we go. Look at the great things he's doing. Oh, by the way, I should say that probably the messaging that you send to your congressperson will differ if your congressperson is a Democrat or a Republican. I'm in this Republican district, and so of course I'm going to pander to the Republican. The Democrats failed to do this, but you guys can do it because you guys are better. But you might want to change your. So send me a note. That's what I'll do. So here we go. Oh, they want to make sure. So 43 because are you really 3636? I think is my. Let's submit this. Okay, so here it is. So let me do this. You know what? I think he'll respond better if he thinks I'm a medical doctor. Okay, so Noonan, 1117. Sorry, it's going to take a minute, but don't worry, I'm going to cut and paste. I've already got it ready. Oh, I did. There's a queue. I don't know that they would notice. I don't think they would care. There's my email. No, I don't want to subscribe. I really don't care if he responds or not. Okay, so what is this? Other. I don't think that this fits under anything other. Maybe it's a safety issue. Yeah, no, I'm just going to go with other. So subject, abolish the time change. So and then I've got just a minute. Let me go find this. I know it's a little bit. It's my first class after break, so you got to give me a little bit of slack here. Why is my mouse not showing up? Just a minute. Now I've got that issue. Okay, copy and paste. Give me a sec. Where is it? Yeah, so you can do the same. Wait, where is it? There, comment. There it is. Okay, there it is. So please bring back. So because this guy's a Republican, I'm going to leave in the bit about how Pelosi is wimpy and couldn't do it. Yeah. So here we go. Oh, I'm not a robot yet again. Let's see. Oh, come on. I hate these. Okay, let's verify. Okay, I guess I'm not a robot. So there you go. So you can do the same. Look at that. Yeah, I'm sure that, I did this. I've done this every year. I remember I get a response every year saying how the person they care. I'll show you my response when I get it. I'll show it on Wednesday. But they always claim to care about the issues that I care about. and that they are fighting for me. And I emailed Pelosi when she was in office back in 2022. I was like, come on, Pelosi, do the right thing. She didn't. But anyway, so yeah, this is I think an important enough issue that you too can join the fun. And you can also go to the White House. That's what I'll do later today, and email them directly. So so if you even if you don't have a congressperson, I just realized some of you might not have congresspeople. You can still just email the White House and say, hey, I'm a student at MBNU, and I think that this is an important issue because I hate changing the clocks. It's stupid. Okay, yeah, be like Arizona. Why does Arizona get to not change their clocks? What's that? Seriously? Why don't I live in Tennessee? Nashville, Trevecca. Yeah, it used to be Indiana used to not change the clocks, but they do. They changed their minds because I don't know. Okay, well, we're going to move on to confidence intervals. I can't see what's coming up for some reason. It's just a blank. Rolling the dice? Really? Just a minute. Oh, now I can see it. Oh, yeah. So I think this was the snow day. We had the die thing, which was kind of a mixed blessing because I didn't have to listen to you guys rolling dice for a whole bunch of times. And I don't know if anyone rolled any dice, but anyway, this is the data from the fall. You have all of these things. Oh, I got to go back here. Rolling the dice. So central limit theorem. So the central limit theorem says that the whole point of the dice rolling thing is this idea that if you have a whole bunch of people gathering data, then your individual samples will it'll be predictable how they are arranged around the truth. So you have the truth, and then each of your samples will be somewhere near the truth, one side or the other, and so, but it's predictable. And that's how statistics, that's sort of the power of statistics, is this central limit theorem. If we didn't have the central limit theorem, we couldn't do all the stuff that we do with statistics. So in this case, and this is the thing that you didn't do, or maybe, I don't remember when I made the video, if I encouraged you to do it or not, or if I just said, hey, I had a class to do it before, and I had my fake students do it. But if you all rolled dice 30 times and averaged together your 30 rolls, then each of you would have a different number probably. I mean, some of you might have the same number. Some of you might be like, yeah, I got 3.133. Hey, I did too. Sure, that might happen as your average. But in general, everyone's spread out. However, everyone's individual rolls will be near the average for the theoretical average for rolling dice. If you look at the distribution for rolling dice, and you work out the average or the expected value. This is similar to what you did on your test with number, where was it? I thought we did it. Maybe we didn't. Did we not? It was on the practice test. Oh, it's up there. Number 4. Number 4, some of you chose not to compute the average. Some of you computed the standard deviation as well, which I didn't give you bonus points, but good job. But anyway, yeah, so number 4 on the test was computing the average value. So we could do the same thing for rolling dice. It's pretty easy. There's a 1/6 chance for each number. You work out the average, it's 3.5. Well, if we all rolled dice 30 times, you would find that your average would be close to that. The standard deviation for all of our averages would actually be this, 0.3. And the way I got that was I used the central limit theorem. The central limit theorem says you take the old standard deviation, divide it by the square root of n, and you get this. And so central limit theorem says that what you're going to end up with is a normal distribution with 3.5 as the mean and 0.3 as the standard deviation. So we're all spread out, but we're all going to be close to 3.5. Some of us will be a little further. And then from that, we can produce what's called a confidence interval. So this, I haven't explained where I got these numbers, but you're going to learn in a minute. So this is the sort of thing that I might come up with based on real data. I'll show you the data. I am 95% confident that the actual average die roll is between 2.9 and 4.1. That may seem like a really large range of values, but I only had this much data to work with. So these are the actual dice data from fall of 2024. I didn't collect your data because we didn't do it in class here because of that snow day. But you notice we have a person whose average die roll was 2.933. There's someone with a 3.2 and so on, all the way down. I've got them arranged in order. The largest was 4.4. So someone who rolled a bunch of sixes probably. But it's natural it's natural to have variation in the sample. And so we're harnessing the fact that the central limit theorem says that the variation will be predictable to come up with the confidence interval. Okay, so here is the general idea. So this is sort of the broad idea, and then we'll do it for real in just a minute. So the broad idea is you have a sample, and that sample is called a point estimate. So that's going to be a single sample. That single sample comes from a population of, like, if you can imagine, let's say that I do a sample, your test average. So I did a sample of you, and I have your test average. So the average test score in this class. But you're not the only class I've ever taught. So I could go back through my time here and gather all the data from all the different samples, all the different classes, and each of those classes would have a different average, but presumably they'd all be centered around some larger average. So you are a point estimate for the population of all students at MVNU who have ever taken statistics. So your average. If we were doing proportions, then we would use a sample proportion, and I think Newton uses a P with a little prime, like a little quote, single quote. So the sample proportion is a point estimate for the real proportion, and these point estimates are statistics. So that's the first thing, is you're going to have a point estimate that comes from your sample. So if nothing else, just remember that X bar is a stand-in for the average for the whole population, and we use P prime as a stand-in for capital P. Now, as far as computing the confidence interval, the way we do it is going to be different for these two things, but in both cases, we're going to rely on the central limit theorem. But before we get to that, let's just talk a little bit more strategy, big picture, and that is that a confidence interval is actually just an interval of numbers and a probability. So we have the point estimate minus some margin of error. You've probably heard the phrase margin of error in various contexts. And so the margin of error just tells you how far away from the truth we might be. What's the chances that we're that close to the truth? Well, that's the probability that we're going to use for the confidence interval. So you have a point estimate minus the margin of error and a point estimate plus the margin of error. Let's see, real world. Okay, so sorry, I moved some things around. I just wanted to make sure that it was all good. Okay, so let's take a look at a pretty simple problem, and this will be similar to what you have for homework for today. For Friday, it'll be a little bit more complicated. So for today, it's going to be simple things like this. I know there's a lot of words there, but let's go ahead and identify the things that really matter. We have a student wanting to determine the mean amount of snow that a certain city receives during the month of April. That's depressing. But I grew up in Rochester, New York, where we had snow in April. It was May before the snow stopped. But anyway, so she wishes to estimate the population mean, mu, which is unknown because there is not a record of the amount of snowfall for every single year. And so what she does is she finds the average of a sample of means. So here, this is important. I'll jot down the stuff that you really want to keep track of. This is her sample mean. So this would be akin to if you rolled a die 30 times. This would be your sample mean. So whatever your sample mean is, keep track of that. And then the margin of error. More on that on Wednesday. We're going to have to deal with how we compute that. But we're going to use Excel to do most of the heavy lifting for that. But the margin of error is 6. So I want a confidence interval for the mean amount of snowfall for this city in April. And this will give me a chance to pull up my attendance. So give me a minute. You go ahead and write down. You're going to have two numbers, by the way. Here. I'll even do it like, I'll help you out. You're gonna have two numbers in parentheses, and I bet you know what those two numbers are, but if you don't, we're gonna get them in just a minute. I have to find my attendance. So bear with me. Just getting back into the swing of things after 2 weeks of spring break. It's challenging. See statistics. Let me just mark. All right, great. All right, random. All right, Oz. Oz, do you know one of the two numbers? You can pick one. I don't care which one. All right, and how did you get that 20.25? Perfect. So it's always going to be like the X bar plus or minus the margin of error. That's beautiful. So this is going to be 20.25, 26.25 minus the margin of error. Let's get that other number, the bigger of the two numbers. Joshua, what do you have? 32.25. Very nice. And how did you get that number? Nice. So X bar plus the margin of error. By the way, notice that this is smaller and bigger. I think, have we had this before? I do this so many times that I don't remember if we've had this in here in a situation like this, but it looks really dumb if you put the bigger number first. I probably won't take off too many points if you do that, but I just want to warn you, don't put the bigger number first, because then I think, what's wrong with you? And so don't do it. Okay, so here's what's going on. Not yet for that. Let's do this. So real world confidence intervals. So you find this all over the place. Whenever you're reading your whatever papers that you read for your psychology class or your biology class, you'll find confidence intervals all over the place. In the news, you'll find confidence intervals. So here's just one, some statistics you can use. How side effects, this is from 2024, so this is almost brand new. How side effects can improve treatment of efficacy, a randomized trial. So these people, here's what they did. This is really shocking on one level. They gave 77 healthy participants, were made to believe that they would receive fentanyl nasal sprays before receiving thermal pain in a controlled experiment. So you can imagine, we're trying to test whether fentanyl actually helps you with this pain, like heat or whatever. And so they give them nasal spray that they say contains fentanyl. It did not. And they then made them hold their hand on like a hot burner. I'm sure it wasn't like 200 degrees. It was probably like 120 or like 50 degrees Celsius or something, or maybe 60. That's not too hot. I mean, you can feel it, but it's not too painful. But anyway, so this is what they did, at least what they told the patients or the participants. What they actually did, there was no fentanyl. What they did, in half of the people, they put capsaicin, which is like pepper spray. So, like here, so they gave some people just a plain saline, and some people got a little hint of, a little burn. You know how it is when you're eating some foods and you get a little burn, it kind of feels good. But anyway, so a little mild burning sensation. So here's the interesting thing about this, though, is that the mild side effects, the people who felt the little bit of burn in their nasal spray, they thought, oh, this must be doing something good. And it actually made them feel less pain. And so here's their paper. But the reason why I put this up here mainly is to show you the fact that there are tons of confidence intervals throughout this paper. You have all sorts of things here. I don't even know what this means, but you have a, wait, no, here, 95% confidence interval. You have that. You have a 95% confidence interval here, and then 95. All of these confidence intervals, every one of them, they have two numbers, and they tell you this 95%. Those are the components of a good confidence interval. If you really want to look this up yourself, there it is. Okay, I'm not going to leave that up there for that long, but you can probably Google it. Probably if you just go to NIH. Oh, does NIH still exist? I know there's been cuts and things taken off the web. Well, it used to be there, and you could look up that number. So 306-09-006. You just look at the video, you can get it. But anyway, these sorts of things, these confidence intervals, they show up all over the place in the literature. So estimates, errors, and confidence intervals. So what we're doing is, oh yeah, now we're back to this. Well, this is boring. Well, you can do this one then. So we have a random sample of registered attendees. We're surveyed and asked if they're learning anything. And the proportion of those who said yes was 0.52. So notice it's a proportion, not an average, but that's okay. We're going to deal with that on Wednesday. And the margin of error is here. So the calculation will be different on Wednesday for margin of error, but for now, it's just given to you. So I want you to come up with a confidence interval for this particular setting. And I'll pick a couple of people. So let's see, I'll put down the pertinent information. So you'll have two numbers. You probably could do this in your head, but I'll give you a minute just in case you want to break out the calculator. So I was just checking my email to see if my representative has responded. He has not yet responded. Maybe before we leave. Okay, so Alec, what do you have for your? Let's do this in order. The lower confidence limit, the smaller number. What do you have for that? Where did you get that 0.48? So you just 0.52 minus 0.04. Very good. So 0.48 is the smaller number. And then Biella, what about the upper confidence limit? Where'd you get that? Just add the two together. Very good. And notice I'm using this language that we're going to use more on Wednesday, lower confidence limit. So here I could even jot this down, lower confidence limit, lower confidence limit, and upper confidence limit, or UCL, which I don't have room for, but you can probably figure that one out. So we'll use that language as we go forward, especially when we get to Excel, because it's helpful to know what these numbers are called. Notice that with this one, as well as the other example that I gave you, we don't have a percentage. So we're not told what the percentage is, but the percentage is going to be is going to affect the margin of error. So the calculation of margin of error takes into account that percentage. So how do we find the margin of error? Oh, okay. So if we have a confidence interval, I guess, so we're going to take this slow again. I forgot how slowly we take this. So yeah, today's homework is super easy. It's like basic algebra. So let's say that we have a confidence interval and we want to know the margin of error. Well, you have a couple of different ways you can do this. Either if you know the point estimate, then you just do the opposite of what you did back here. Back here, you said you added. Well, let's subtract. So basically figure out the difference between the middle and whatever side. But if we don't know the point estimate, if we just have the confidence interval, then we will take the size of the confidence interval and divide it by 2. Let me demonstrate this with this paper that I showed you about the capsaicin and the point of this paper, just the statistics you can use, is that if you have side effects when you take drugs, it actually, at least according to these guys, it actually improves the results. Like you actually, at least when if it's pain or whatever, I don't know. But anyway, let's take this one for example, 1.29. Let me write this down. 1.29 and 7.51. 1.29, 7.51. So if we're given that, does it tell us the actual? Oh, it does. It tells us the. Is this? I don't know which of these. See, I didn't read this really carefully, to be honest. I just read the abstract and I thought it was funny. So, and I saw confidence intervals, so I got excited. But anyway, let's see. I'm guessing that that number is the point estimate. That I don't know what that is. That might be the standard deviation, but let's find out. So if you have this, this is the lower confidence limit. This is the upper confidence limit for this particular whatever that is. If I want to find the margin of error and the point estimate, what I'm going to do, probably I would find the point estimate first. So X bar is actually going to be the middle of this range. So if you think of a confidence interval as being whatever your point estimate is plus or minus the margin of error, then whatever's in the middle is going to be the point estimate. And so in this case, I don't have my calculator, I guess still resetting from the break. There's one here. So to find the point estimate, find the point estimate, 7.51. Actually, these numbers I should be able to do in my head, but it's early. 8.8, so I get 4.4. So I get 8.8 divided by 2, which is 4.4. And so that wasn't that what it, yeah, that was, oh, wait, no, that isn't. Weird. I don't know what that is. Well, I'm going to go with this. I don't know. Like I said, I didn't read the paper, to be honest. I just looked at the abstract. I thought it was funny. Anyway, so that's the middle, or yeah, that's the middle. So that would be the point estimate. And then the margin of error is you can do this one of two ways. I'll do it the easy way. Since I have the middle, I'll just subtract off the lower confidence limit. It's just basic algebra. So let's see, 4.4 minus 1.29, which I should be able to do in my head, but I didn't. So there it is, 3.11. So this particular confidence interval could be written like this, 3.11. Yeah, so I don't know what the paper was referring to. Honestly, don't care at this point. Want to move on rather. Okay, so let's see how you do. Let's see. So here I've got a series of problems. The first one, this is the same as this one. So these are the same. I want to find the mean and the margin of error. So notice the only difference there. So we'll do one of them and then the other. You decide. You're going to have to do both of them, the mean and the margin of error for this particular confidence interval. Well, Gracie, which one did you do first? Did you do the margin of error or did you do the mean? The mean, okay. So what did you get for the mean? Wow, how did you do that? Perfect. 54.2 plus 56.5 divided by 2. A little bit of a mess there, but there it is. Beautiful. Okay, so let's do the margin of error now. So let's see, August, can you do the margin of error for us? All right, can you tell me what to do? And I could do it for you? That sounds good to me. And that's going to give me 1.15? All right, whoops, what just happened? Oh no. What is going on? Sorry, I didn't realize I touched the wrong thing. Like I said, you take 2 weeks off and things happen. Okay, that sounds pretty good there. By the way, that's not the only way to find this margin of error. Whoops, there it is. There it is. The other way to find the margin of error, I don't know if anyone did it this way, but another way is to do this. If you have the interval, you could do this, and I kind of hate to show you this because this might cloud some of your thinking, but take the difference, divide by 2. So if you take the difference between those two, I don't need a calculator for this. This is 2.3. And you get the same thing, 1.15. So it is possible to find the margin of error first. And if you do it that way, then the benefit is that it's really easy to find the mean or the middle, because you just take this 54.2 and add to it the margin of error, and you get 55.35. So there's 2 ways of going about that. Let's try this with another one. Here we go. Oh yeah, and then we're almost done. So we are going to end a little bit early so that you can talk to me about your tests. But I need to talk about projects as well. So I see it on my list coming up here. So margin of error. Oh, here we go. Same deal. You need to. I know it just says margin of error, but you're going to find the proportion now, because this is a interval for a population proportion. So take a minute and work that out while I get set up for explaining the project situation. Okay, switch back. All right, let's see how we're doing. Pardon me. No, not here. Okay, so Elizabeth, what do you think? How, would you like to find the proportion or the margin of error first? Well, which one did you do? Okay, why don't you find the proportion, the middle? That sounds pretty good to me. Let's do that. So that's going to be 0.74 divided by 2. And you got 37, is that right? Good job. Excellent. So 0.37 is the population, or not the population, the sample proportion. I suppose I should put a little prime there to indicate it's the sample proportion. So that's the middle. And then the I need the margin of error. Margin of error. And who? Oh, Abby W. Abby W. What did you get for your margin of error? It is. How did you do that? Perfect. So there's a couple ways you could do it, but yeah, take this 0.37, subtract off 0.33, or subtract 0.37 from 0.41. However you do it is fine. Good job. So however you do it. Now, here's a quick picture of what this looks like. Is that if you think of this one sample as representing like just one of many samples, then if you took all of the samples, you would have this normal curve that would be centered around the truth. The confidence level, we'll have to deal with that more on Wednesday, but the confidence level just tells you how confident you are that you're close to the truth. So this confidence level, if you make it big, if I'm 99% confident, for example, then I'm going to have to widen this out more. If I'm less confident, let's say I make a 90% confidence interval, then it'll be a little tighter, a little bit smaller. The standard is 95% confidence interval, just because that's a good number. You know, that means you're probably going to be right 19 out of 20 times. 1 out of 20 times you're going to be wrong in your prediction. But this is sort of a picture of what we're doing, is we're saying, okay, if this is what the population looks like, then my sample is going to be somewhere in here. So I can just, make a sort of a similar picture using my sample at the middle, and there will be a 95% chance that the truth is within that margin of error. Okay, let's switch gears just briefly. Let me make sure, does this matter here? No, I don't care about that. Switch gears just a bit for a couple of minutes. So the projects didn't quite go the way that I was hoping, and so I've shifted gears. So let me just quick explain. So projects. I did go through, you have grades for your project 1, which basically was almost no effort. Hopefully it didn't take much effort, the choosing your data set. So in the past, I've done 2 different versions of projects. The version that was the cooler version, which I apologize we're not going to do this semester, is where you choose a data set and then you work with it to do various cool things. The second version is where I give you a data set and then you do the cool things with my data set. That's easier for me, and I may be easier for you as well. And so in that regard, you should be thankful because this is going to be a little bit easier. So we're using baby data for this. Yeah, so we'll talk about this more on Wednesday, but I wanted to mention that I did put in grades for those of you who did the project 1, and then those of you who chose not to do project or the first project, you'll be able to make up for it by doing these projects. So if you want a quick preview, this one is going to be due next Monday. I think that's when I have it due. Wait, it's due Monday. Oh, no, 2 weeks. 2 weeks you have. That's a long time. So in this one, you're going to be working with the baby data that I mentioned at the beginning of class. This is the full moon data and whether babies are born on full moons, more prevalent than other moons. But anyway, I have here a playlist that includes all of my work. So you can look at that if you need to or not. But you might want to at least glance at it to see what sort of format I'm looking for and so forth. But each of you are going to be working with a slightly different part of this project. So your job is basically just construct a 95% confidence interval for the number of births on a given gender, day of the week, moon phase that you're assigned. And the assignments are listed here. Let me just show you that, and then we'll wrap things up. So when you click on that, here's what it looks like. I guess I've clicked on it many times because it says there's 3 of them. Why is it not showing up? Come on, buddy. How many times do I? Okay, just a sec. I guess I'm just going to, either it's not downloading. Oh, here, finally. It's opening up on this screen. I don't know what that is. Let's get rid of this. Just a minute. Okay. Hold on a sec. Baby data project assignment. There it is. Okay. So here's what if you look at that assignment list, it has your names, and then it has your assignment. Whoa, here we go. So you can see your name is over there, and then like, for example, I'll just go down. You can look this up yourself, so you don't have to memorize your own. But here, I just put myself at the end so that you could watch the videos that I made last semester or the semester before, have me doing this situation where I am number 1. What is number 1? 7, I believe, is Saturday and boys. So I will make on my video, what is 1? Full, new, or neither? I think, I don't know what 1 is. Oh, it probably says in the assignment. So I don't remember if that's full or new. Yeah, I think it's full. Full moon, Saturday, boys, and my confidence interval is the confidence interval for the number of boys born on a full moon that is a Saturday. And so you can watch the set of videos. You're going to make something similar, but I would suggest not starting this until Wednesday, because on Wednesday, we're going to put together a spreadsheet that I'm going to call Confidence Interval Gold. And the reason why I call it Confidence Interval Gold is because it is like gold. You don't want to lose it. It is so valuable that you're going to use it for your homework and for things like this project. So we'll do that on Wednesday. Make sure you bring your computers on Wednesday so we can do that. Stick around if you want to complain about the way I graded your test, or if you want to talk about anything else. Otherwise, we'll see you on Wednesday. We're done a couple minutes early. You have time to get